thank you so much for having me here today. So my name's Mark, and I'm a contributor to the Optimism Collective, and I'm here to talk about the future of interoperability. So let's start and let's talk about what is the superchain. So the superchain, very simple definition, optimism governed block space. But there's more. It is also a horizontally scalable cluster of chains with shared security. It is also a mechanism to turn zero-sum games into positive-sum games. It's also infrastructure for the institutions of the future. And it's also the substrate to align AI. It's really important that if we have superintelligence, it's financially aligned with us. Cool. So let's talk about a little context, just so we kind of know why we're doing this. We're interested in scaling Ethereum. So the problem, right? We can't fit global demand on a single chain. No matter how hard anyone wants to try, it's impossible to put everything into one computer. There's a lot of technical challenges here. If we look at the way that Web 2 scaled, they scaled to global demand using many computers. We have many computers in our pockets today. It's just really hard to build one big computer. There's also the social problem of scaling a single computer because the governance over the roadmap. People might have different preferences on what to build next or where to go with the project. So the solution, the roll-up centric roadmap. So at a high level, roll-up centric roadmap, basically the idea is to leverage L1 for consensus and availability, and then utilize a marketplace of L2s that are all cooperating and competing with each other to basically scale Ethereum so that users can use Ethereum very cheaply. But there's problems with this. This is what we're facing right now. There's a lot of fragmentation. It's a zero-sum game for usage. Like chains are kind of all competing for users, and it feels like people are upset when a project chooses to deploy on one chain versus another chain. So the solution, interoperability between chains. Cool, so with interoperability, there's kind of two ways to think about it. There's application layer interop, and then there's native interop. Hart was just up here before me talking about application layer interop. This is a really good solution when you're going between ecosystems. I'm here right now to talk about native interoperability. So with app layer interop, there's often assumptions about finality because you run the risk of one chain not finalizing and then a double spend or something. A lot of times there's fungibility problems where using one bridge, you might not end up with fungible assets if you use a different bridge. There's liquidity problems where some of these bridges don't work well with long tail assets. And there's also a lot of bridge hacks. So native interop, on the other hand, it is consensus aware. It is built into the actual protocol itself. So this means it only works really well within a particular ecosystem. And as part of the design, the fork choice rule of the blockchain itself is aware of the interop rules. And the proof for withdrawals is aware of the interop rules. So what this allows for is a more cohesive experience. And this looks like for application developers, it's way easier to build fungibility into assets. Cool, so now I'm gonna talk a little bit about how we're building this into the OP stack. So this is a big chart. I'm not gonna go super deep into it, but we'll cover some highlights. So cross-chain message, high-level idea in an interoperability scheme, at least in this one, you have to send 2 transactions. You send one transaction to the source chain that kind of kicks off the cross-chain message, and then you send another transaction to the destination chain, which kind of finalizes the cross-chain message. We call the first transaction an initiating message and the second transaction an executing message. So, what is an initiating message? It's literally any log that is emitted by a blockchain. So, what is a log? It's like in Solidity, you can emit an event. So what does this mean? All applications that emit events, which is most applications, they immediately become interop compatible. So developers don't need to think about new mental models. They can just instantly start exporting the data that they're creating to other chains. So how does it work? There's this idea of an identifier. So the identifier is able to uniquely identify a log. What information do you need for this? You need a chain ID to know what chain emitted the event. You need a block number to know which block includes the event. And then you also need a log index. So using those 3 pieces of information, you can point to any event from any chain in the superchain. So now the executing message, right? The executing message is made up of the initiating message, so like the log that the application wants to, consume and send across chain, and an identifier. And basically, the invariant is that the canonical chain will only include valid executing messages where the identifier and the initiating message that it includes, they match. So this is a little pseudocode in how you would go about, doing this verification. Any invalid executing messages are reorged out of the chain. So what this means is that as an application developer, you don't need to think deeply about the validity of a message. All messages that you process, you can guarantee that they will be correct. Otherwise, the block containing that message will get reorged out. So there's this idea of the dependency set. So the dependency set is basically, it defines the set of chains that are interoperable. A chain operator can say, this is the set of chains that I am allowing inbound messages from. And basically this exists to guarantee an upper bound on the resource consumption of the entire cluster. And in the future, we would like to figure out how to engineer out of needing this by leveraging some sort of zero-knowledge proof system. And currently, every chain includes itself in the dependency set. So this means that you can instantly start, consuming your own logs as an application. And in the future, it'll include L1, meaning that all of the logs that are created by applications on L1 will be consumable on L2. All right, shared security. So all of the chains within the same cluster will share security and finality. So this gives a cohesive developer experience when you are developing within the superchain. With the shared security, it's way easier to build fungible assets. We published this ERC 7802, very simple interface for minting and burning tokens. And we're going to be building on top of this to make it really easy to build ERC20 tokens that are fungible and portable across the superchain. There's also this idea of a shared lockbox. So what this shared lockbox is for custodying all of the ether that is deposited into the superchain. And it exists to guarantee withdrawal liquidity. Because you can imagine that as people are sending their ETH between different chains and they want to withdraw, if the ETH is not all in a single place, they might not have liquidity to withdraw from in the bridge that they're trying to withdraw from. So now I'm going to talk a little bit about layers of abstraction. At the lowest level, you can kind of think of it like multicast UDP. This is useful for just reading arbitrary logs. Then on top of it, we have a messenger that is useful for making cross-chain calls. Then we have superchain ERC20 built on top. So a lot of people asked why another standard. This standard is very simple and compatible with other standards like XERC20. Cool. So now I'm going to talk a little bit about app design. All right. So today, applications, they're often built for a single chain. When you want to deploy to another chain, people will literally just take that same application and copy and paste the deployment to another chain. This results in liquidity fragmentation problems between the chains. We're seeing this today. It also means that every instance of the application inherits the scalability problems with that chain. And this also means that the user experience of the application can vary dramatically between different chains because some chains are faster. Some chains might have slightly different features. So this is just because we're so early, really. So I think that we need to learn from Web 2. What does this mean? We need to start thinking about chains as microservices in a bigger architecture, right? The idea is to stop building apps like literally like blockchain applications. We should stop building blockchain applications and we should start building applications that use blockchain, right? We should start thinking about chains as threads for your applications, for your smart contracts. So how do you go about this? The first thing to do is think about your app and identify subsystems of your app that do one thing well and can be horizontally scaled. This can allow you to kind of shard your gas bottlenecks across multiple chains to keep costs low for users. And in an ideal world, we can auto scale with the usage. This is how Web 2 scales to global demand. So let's walk through some examples. We've got DeFi. You could imagine a horizontally scalable on-chain order book where all of the orders are deterministically placed across many chains. And if these chains could automatically turn on as more users started using your app, then you'd smooth your base fee across many chains and you'd be able to keep fees low. Now let's think about an NFT marketplace. So an NFT marketplace can have this idea of like, minting and trading. They're two distinct ways that users can use the app. So under this philosophy, you can take a horizontally scaling minting engine and separate it from a horizontally scalable matching engine. And ideally, the minting engine is just going super, super fast, like constantly just minting new NFTs because there's tons of users and we're just minting more and more NFTs. And the matching engine is its own horizontally scalable cluster, and it's constantly just matching trades and accepting orders for people wanting to sell. So we have a lot of work to get to this world, like a lot of work. We need some core primitives. So we definitely need a smart contract wallet for this. We need some sort of smart contract wallet that it's really easy to deploy across many chains, and when a user signs something, it needs to not bind to a particular chain, a classic intent sort of model. We also need some idea of distributed storage. What does this even look like? We need some sort of abstraction or library that developers can use that they can easily read and write to storage across many chains. We've actually been working on this promise library, which is pretty cool. You could imagine, if you had promises in Solidity that allowed you to, read from other chains with a familiar abstraction. We also need a multi-chain RPC. One of the goals of the superchain is to make it feel like one network and make sure that every time a new chain is added to the superchain, your application instantly becomes more scalable. So we need some sort of multi-chain RPC that aggregates all of the data together and is backwards compatible with wallets like MetaMask or Uniswap wallet. Cool, so just gonna talk a little bit about contributing. All of our specs are open. Please check this out. Please leave comments. It's really important that the specs are open so that everyone knows what they're using, and it makes it easier to onboard new people to contribute. We're also open source. This is free software. It's really important that anybody can, take the code and play with it, modify it however they want, deploy their own instance. Like, I think it's a fundamental human right for people to be able to deploy their own rollup and transact on it however they want. So, we're working on some public DevNets. At the Edgelana Hackathon last week, we launched the first interop DevNet, and it was a lot of fun. We were able to send transactions back and forth. More DevNets to come. We're going to continue improving them and adding more features. And you can follow along right here. This QR code links to our docs, and it'll contain all of the information to connect to our DevNet. Cool, thank you.